So we want to take a look at these three factoring problems that you had for your bell ringer. So what's the first one? Factoring by what? What are we factoring by? What are we doing here? Greatest common factor. And what is the greatest common factor between these two things? X. So it's like reverse distributive property, right? We're going to pull that X out, and then we're left with an X from the first term and a 4. Now, Felipe, we talked about that being a perfect square, the 4, right? But it's not a difference of perfect squares, and also this X is not a perfect square, so we can't do anything else to that. We can't go into difference of perfect squares there. So that would be your final answer. Okay? How about number 2?
Difference of perfect squares.
That's a difference of perfect squares because we got subtraction. Both of these are perfect squares, and so that becomes what? X plus 5 and X minus 5. Okay? And then number 3 is what? We got a trinomial, right? Leading coefficient of 1. That ought to scream at you. No GCF. So we need to do what? Big X. Absolutely. Reminder, when you do big X, the last number, the C term, goes in the top, and the B number goes in the bottom, and we need to multiply to get 2 and add to get 3. 2 and 1. Perfect. Does it matter which one goes on which side?
No.
Not in the slightest. So that means we have X plus 2 and X plus 1. Okay? Now, up to this point, and there's a reason I picked these 3 problems for your bell ringer today because it goes right into what we're doing. Up to this point, this is all we've really done with factoring. And anytime we've ever done these problems, it's never been equal to anything, right? It's always been just the idea, just the concept of factoring. Today, we want to take that idea of factoring and talk about equations and how they work together with equations. Okay, so I'm going to flip mine over, but if y'all will go to the notes page, okay, solving quadratic equations by factoring. So first off, I want to talk about this word quadratic, okay? We've talked about this form before. The standard form for a quadratic is ax squared plus bx plus c, where a, b, and c are some real number, okay? For us, right now, we'll be working with integers for a, b, and c for the most part. Now, you could have all 3 of these terms, okay, but you don't have to have these last 2 for it to be quadratic. As long as you have the x squared, as long as x to the second power is your biggest exponent, okay, variable to the biggest exponent, that's considered a quadratic equation. Does that make sense? Okay, so I want to look at this first one, and I want to point out some things. So in your bell ringer, we only had this, right? This was the final answer. Does that make sense? Does that look like what we had in our final answer on the previous one? So it looks like we've already done big X. Okay? Somebody's already done big X here. Now the difference is we are setting it equal to 0. Quadratics are pretty interesting when you set them equal to 0. It's called finding the solutions. Okay? In other words, I need to figure out what value of X would make all of this equal 0. Okay? So first let's talk about what this says. That says X plus 6 times X minus 8, right? So we're multiplying these 2 things together, these 2 binomials together. Does that make sense? Now, remind me about multiplication being equal to 0. If you multiply 2 things together and it equals 0, what does that tell you? One of those things that we multiplied had to be 0. Does that make sense? Okay, if you're multiplying 2 things together and it's going to equal 0, then one of those 2 things had to be 0. So when we solve a quadratic, once we get it factored, what we do is we set each of those individual factors equal to 0. Okay? And that gives us, normally, there will be 2 solutions. Okay? Now that we talk about some examples later where there may not be but one solution, or there may not be any solutions. But right now, pretty much all the ones we're going to focus on today are going to have 2 nice, real whole number solutions. Okay? So, either this first binomial is going to equal out to 0, or the second one's going to equal out to 0, so that the whole thing will go to 0. Okay, so this is a one-step equation we can solve very easily. What would I need x to be, or how would I solve that? X plus 6 equals 0. What would I do to both sides? Minus 6, absolutely. So once we get to this step, the math is very straightforward. So x equals negative 6, or if we solve this one, x equals 8. Okay? Point being, if we were to take negative 6 and plug it back into this equation for both of those x's, like negative 6 plus 6 and then negative 6 minus 8, and multiply it all out, it would equal 0. The same thing would happen if you plugged 8 back in, because 8 minus 8 is going to be what? 0. And then you have 0 times 8 plus 6, which is 14. 0 times 14 is going to equal 0. So as long as either one of these factors goes to 0, the whole thing will go to 0. Does that make sense? Okay, so that's the idea. That's what we're doing here. All right, so let's take a look at number 2. What two things are being multiplied together here? Obviously, this is not this wasn't a big X one. This is just a GCF one. They pulled an A out of that, right? So what's multiplied here? We have A times A minus 4. Okay, so the two factors are A and A minus 4. So as long as either one of those is equal to 0, then the whole thing will go to 0. Does that make sense? So either A equals 0 or A minus 4 equals 0. Well, I don't have to solve the first one, but I do need to solve the second one, and it's just a one step. So when A is 0, this whole thing will go to 0, or when A is 4, this whole thing will go to 0. So we have two solutions.
So which one would you plug in, 0 or 4?
That's what I'm saying. Either one of those would make this statement true. So, like, remember last year when you were in ninth grade and we solved equations, right? You always ended up with x equals one number. And that was the answer. It was that one number. Well, with quadratics, you have more than one possible answer. We have, in this case, we have two solutions. And most of the ones we're going to be looking at over the course of this week will have two solutions. Some quadratics have one solution, some have none, and we will get to those. But for now, we're going to focus on the ones that have two nice, real whole number solutions. Okay? All right. So let's take a look at number 3. Obviously, number 3, they have not factored it yet. So when that's the scenario, the first thing that we need to do is to go in and factor it. All right? So we got a trinomial here. So what do I need to do? Big X. Absolutely. So we're going to start with that. Okay? What goes in the top? Negative 21. Make sure you bring that minus with it. And then in the bottom, we've got the 4. Needs to multiply to negative 21 and add to 4. Negative 3 and positive 7. Okay, and it's good that you said that the 7 needed to be positive so that it could add up to a positive 4, right? So that means I'm going to rewrite this as x minus 3 and x plus 7. And then set it equal to 0. Okay? From there, we're going to treat it just like we did number 1. Either one of these can be 0. Doesn't matter which one. So I set each one equal to 0. X minus 3 equals 0. X plus 7 equals 0. And then when I solve for those, I get x equals 3. When I subtract 7, I get x equals negative 7. So those are my two solutions here. Just grab your seat, dear. We're taking some notes. I'll catch you up here in just a second. Here you go. Fill this in. Follow along with it. All right. Does that make sense? Does anybody have any questions at this point, guys? Y'all okay? All right. Take a look at number 4. Take a look at number 4. We're going to treat it the same way, correct? The first thing I need to do is big X that. In the top, we have negative 4. In the bottom, we have 3. What multiplies to give me negative 4 but adds to give me positive 3? Okay, now let me ask you a question. If I do a negative 4 and a positive 1, what's that going to add up to? Gotcha. So we got it backwards. So let's do negative 1 and positive 4. Okay? Now, Captain, I want you to think about the two numbers that you just said. In just a second, those numbers are going to come back. All right? So we have b minus 1 and b plus 4. And we're going to set that equal to 0. And then we take each of those two factors and set those equal to 0. Now, Catherine, I know you think I called you out, and I wasn't trying to do that. But, Catherine, look at my final answers. Look at my final answers. Those are the numbers you said, aren't they? That's what you meant the whole time, isn't it? Exactly. There we go. All right, so one thing you will always notice, and Catherine, this is a really good point to make, and it is for everybody in here. If you haven't figured it out yet, the numbers that go in your factors, right, whether it's addition or subtraction, the opposite of that will be your solution pretty much every time. Now, we will talk about a little variation there when we start having things other than, we start having to divide by things other than 1 potentially, but that'll come later. Like you can get fractions for answers and things like that. But that'll come later, so we're not going to stress that today. All right. Tell me about number 5. We got 2 more examples that I want to get done today, and I want to take a look at those because they look different. What's different about these? It's not equal to 0. Could we make this be equal to 0 pretty easily? Probably. What can I do to this to make it be equal to 0? How could I get that minus 30 off of that side? You could add 30 to both sides, right? Do it once to each side. And then that's, of course, going to go to 0. And then over here, all we're going to do is rewrite it. M squared minus 11m plus 30. Okay, now it's set equal to 0, so now I can do my big X, right? Okay, so just make sure it's set equal to 0. That's why we threw those examples in. All right, we got 30 in the top, and we got negative 11 in the bottom. So 2 numbers that multiply to give me positive 30, but add to negative 11. Negative 5 and negative 6. So we're going to have m minus 5 times m minus 6 equals 0. And then from there, what do I do with each of those factors to solve it? Set each one equal to 0. And then we're going to start, and then we're going to add. Okay. So m minus 5 equals 0. M minus 6 equals 0. And then for this first one, we would add 5 to both sides. And for this one, we would add 6. So our 2 solutions are 5 and 6. Okay? And these solutions, in the second half of this unit, so after the first test in this unit, we'll start graphing some quadratics. Okay? And when y'all do that, y'all start to see what these zeros really look like. Basically, they're x-intercepts. They're across the x-axis. But we'll get to that later, so don't overthink that or stress it. Right now, we just want to get through the process of continuing to practice factoring, but then solving for it or setting it equal to 0. Okay? All right, one last one. This time I got 15x on the side by itself. How could I get this equal to 0? Yeah, you subtract 15x, absolutely. So it doesn't matter which term is on the side by itself. We can just add or subtract it to get it on the side with the other stuff. Okay, so that goes to 0. That means I have x squared. Now, I will say this. Pay very close attention here. I do want to put it in standard form, like in the correct order. So that minus 15x is going to come in the middle. And the 56, the whole number, is going to come at the end. Did everybody see that step real quick? Did everybody see what I did there? You definitely want to put it in that x squared, then x, and then the one that doesn't have an x. You definitely want them in that order. All right, Shay, what were you going to ask?
So is that where the thing at the top comes from?
The thing at the top, you mean these?
No, above.
Oh, this. Yes, that is standard form for a quadratic equation. So you always want and basically that's what we're dealing with here at the bottom. It's just A is a number, B is a number, and C is a number. Yes, correct. Okay. All right, so Shay, if we wanted to, we could talk about what A, B, and C are here since you mentioned it. So A is 1, B is negative 15, and C would be positive 56. So that's the A, B, and C part. And that's why when we talk about the big X, Shay, we talk about C goes in the top, B goes in the bottom, and then we talk about what numbers multiply together to give you 56, but add to give you negative 15. All right? And what would those two be? Negative 8 and negative 7. Very good, Catherine. All right, so then I'm going to rewrite those. All right, so that would be x minus 8 and x minus 7 equals 0. All right, set it equal to 0. And then I'm going to set each of those factors equal to 0. And to finish solving, add 8. So x equals 8. Add 7. And there's your two solutions.